Node is the smallest individual unit that we have in the linked list, which has got two parts. It reduces a lot of time to access a particular data. So traversing, in the sense, you will be visiting each and every node one by one. So that is what we call it as a traversing linked list. So guys, insertion and deletion will happen in both ends. Hello everyone, I welcome all of you to the yet another interesting session. It's all about the linked list. So guys, in the beginning sessions, I have given you a brief knowledge about the linked list. So what exactly the linked list is all about? So let us understand the theoretical concept of the linked list in this session. But the program implementation, let us do it in the lab when you come to the lab. Alright, so without wasting much of your time, it's time to check what exactly which I'm going to discuss in this session. So guys, I will be discussing the introduction about the linked list. I'll give you the brief idea about what exactly linked list is all about. Then after that, we will discuss the different types of linked lists that we have. The first one that we have is all about the singly linked list, doubly linked list, and the circular linked list. That is what we have in this session. So without wasting much of your time, it's time for all of us to get into the session. Yes. So guys, introduction about the linked list. It is a very simple concept. So what exactly you need to remember is, whenever I say linked list, the first thing which should come to your mind is node. Node is the smallest individual unit that we have in the linked list, which has got two parts. The first part, we always store the data, and the second part, we always store the address of the next node. So that is what you need to remember with respect to the node. So linked list is a combination of nodes. It is the smallest individual unit that we have in the linked list. How many parts do we have in the node? We have two parts. One is for data. Whatever I want to store, I can store in this data. What is this? Address. What address? This is the address which tells me where exactly the next node is there. Okay, the reference to the next node. So that is what I will mention it in the second part. That is what you need to remember with respect to the node. So fine. Linked list. Observe here. Linked list is a very commonly used linear data structure. Linear data structure, in the sense, you all know all your data will be in the sequential format. That is what we call it as a linear data structure. So fine. Each node we have already discussed holds two things. One is data, another one is address. Fine. Linked lists are used to create, observe, we can also create the trees and graphs using this linked list. So you can also create trees and graphs using this linked list. So fine, you got the basic idea. Moving forward, why should I use linked list? What is the advantage? We have stack, we have queues. And when we have stacks and queues, why should we use this linked list? Let us check that. They are dynamic in nature, which allocates the memory when required. It is very difficult for me to allocate the memory dynamically for the queue and stack, but it is not like that when it comes to the linear linked list. So when I have the linked list, dynamically I can reduce or I can increase the memory. That is one of the advantage that we have. So fine, the next one, insertion and deletion operation can be done easily. I don't have to worry much. I can insert or I can delete the nodes to the linked list. It is very, very easy. So the next one that we have is stacks and queues can be easily executed with the help of the concept called linked list. I can also implement the concept of stacks and queues with the concept of linked list. That is what you need to remember. That's one of the best important point that you need to understand here. So fine, and linked list reduces the access time. So I don't have to spend a lot of time like how I spend in stack and queue. It reduces a lot of time to access a particular data that I want. That is a major advantage that I have with respect to the linked list. Moving forward to the disadvantage. When it comes to the disadvantage, what is the disadvantage that I have with respect to the linked list? So let's check one by one. Memory is wasted as the pointer requires an extra memory. Observe here, I'm not doing anything else. I'm just storing the reference of the next node. So this is not helping me at all personally. So again, this is a waste for me when it comes to the concept of memory. So that is one of the drawback that I have with respect to the linked list. Second one is no element can be accessed randomly. If you want to access anything, you have to access sequentially, one after the other. That is again one more problem. Randomly, directly, I cannot access this. You have to access this and then only you can access this. So that is one more drawback that I have here. And then the next point that we have is reverse traversing is very difficult. So guys, what is the meaning of reverse traversing? So you can traverse, you can visit the elements, first this, next this, and next this. You cannot come back. It is very, very difficult. That is what they are saying that as a disadvantage. So this is the few disadvantages that we have with respect to the linked list. Moving forward, that we have applications of linked list. Where I can apply this, where I can use this linked list, that is what we are trying to understand. Linked list can be used to implement stacks, queues, and graphs, and also trees. That is what we have discussed earlier, right? So that's one of the advantage that we have. So it's like a rice. If you have rice, you can make chitrana, you can make rice bath, you can make pulao, you can make biryani. So that's a concept. If you have linked list, you can implement stack, you can implement trees, you can implement graph. That's the advantage of the application that we have with respect to the linked list. And linked list is yet to insert, okay, let you to insert the elements in the beginning and in the end of the list. But when it comes to the stack, observe, this is one of the important point. When it comes to the stack, guys, insertion and deletion will happen in the only one end. But when it comes to the queue, so guys, in the simple queue, what happens? Always the insertion will happen at the rear end, deletion will happen at the front end. But when it comes to the linked list, so guys, insertion and deletion will happen in both ends. That's the advantage in the application that we have. And then in the linked list, we don't need to know the size in advance, since it allows me for the dynamic allocation of memory during the runtime. You don't have to know the memory in the beginning. That is one more advantage that I have. Whenever I need, I can start allocating the memory to my linked list. That's an advantage that I have with respect to the linked list. Moving forward to the types of the linked list. As I told you in the beginning, when I'm discussing the agenda of the day, so I have mentioned, we have three different types of linked list. The first one that we have is all about the singly linked list, which we have already discussed. That's a basic type of linked list. So next one that we have is doubly linked list and circular linked list. It's a very simple topic, or if you find it difficult, let me make it very simple to you. So what exactly is singly linked list? We have already discussed. So the first node will be pointed by the head node. So this is the first node. All right. So this head will point to the first node and it will have two parts. You all know that. One is for data, another one is for the address, which points to the next node. So at the end, so it will have null in the last node. Suppose if this is the last node, so it will store the null. Okay. This is what you need to remember. This is the singly linked list. Whatever the concept till now we have discussed, this is that concept completely related to the singly linked list. But now, so guys, when it comes to the doubly linked list, observe what happens. Doubly linked list has got three parts in the node. When it comes to the singly linked list, we have two parts in the node. But when it comes to the doubly linked list, we have three parts in the node. Sir, why do we need these three parts and what are we doing it with the three parts? Sir, what happens with this part of the node is it contains the address of the previous node. And this contains the address of the next node. And the middle part is to store my data. The memory wastage is more in the doubly linked list than compared to the singly linked list because we are using two references in the node. That is what you need to remember. Sir, why? What is the reason that you have two references here? Can't you just manage with one reference that which was pointing to the next node? My dear students, as I told you in the beginning, the drawback, when I was discussing the drawback, traversing back was a difficult and was a drawback that I had in the linked list. But here, since I have the address for the previous node, so it is very easy for me to traverse front and back. That is the major advantage that I have with respect to the doubly linked list. So guys, this will give me the next. Observe here. Here I have the address of the previous node and this has got the next node. Same thing happens in all the nodes, which will help me to traverse front and back. That's the advantage that we have with respect to the doubly linked list. And I have circular linked list. So it's very, very simple. Circular linked list in the sense what? The last reference will be pointing to the first node. Again, that's it. You're making a circle. So how we discussed the concept of circular queue, same concept we are using it. So the last reference node, so this will refers to the first node. So that is making the circular linked list. Now let us understand this in detail. What are the different types of operations that we can perform with respect to the singly linked list? Yes, we can perform the insertion and we can also perform the deletion, and the last one is traversing. How are we trying to perform this insertion in the singly linked list? Let us understand that. So guys, insertion at the beginning, okay? This is what I can perform in the singly linked list. Let us try. Let me just show you how do I perform the insertion at the beginning. Imagine this is the head. Okay, let me just take this. This will be very easy for you. Insertion at the beginning. This is my linked list, right? So imagine I have 3 nodes, okay? I have 3 nodes. Correct. So what is the first node that I have? I have 3. Okay. So next one is 10. Next one is 2. And this is what I have. Let me just make it as last node. What is that we are trying to understand? So this head, okay, head is pointing. So head is pointing to which node? To this node, right? So instead of this, what I will do is I will create one more node. What is that I have to do? I have to create one more node. So fine. After that, you have to save the data. Let me just insert 4. So fine. So in this address part, I should store the address of this node. I should store the address of this node and then I should refer this head to this node. That's it. This is how I perform the insertion at the beginning in the linked list. Hope you understood. What is the first thing? So first you have to create the node. Then you will insert the data. Then you will save the address of this node and then you will refer this head to this node. That's it. That is what we call it as an insertion in the beginning. So fine. What is the next one that we have? Let me check. Insertion at the end of the list. It's very simple, guys. So let me take the same example. So I need to insert at the end. What should I do now? So I will create same thing. I will create one node and then I will place the null here. Okay. I will place the null here and then here I will store the address of this node and I will place the data. So before I place all these things, I have to place the data. Let me just show you one more time. What is the first thing? I will create the node, then you store the data and you make this as null and then you refer this. Here you will store the address of this node. That's it. You are going to insert the node at the end. There is no changes that you have to do. This is very, very simple to understand the concept. When it comes to the program, I will show you in the lab how exactly we will be doing this with respect to the program. The next operation what we have is insertion after a specified node. Okay, so fine. It's very, very interesting. So you should know this. Okay, let me just erase everything. Insertion after a specified node. Okay, so imagine I need to insert after this node. How do I insert? So same thing. First I will create one node. Okay, so fine. After that you will insert some data to this node. Let me just write 20. Okay, so what I will do is here in this part I will store the address of this node. I will store the address of this node. Okay, so in this part I will store the address of this node. That's it. This is how I insert the data in the specified part. This is all about the singly linked list. All right, so moving forward to the next one that we have. So I think we are done with this. The next one, deletion at the beginning. It's very simple again. So deletion at the beginning. So how do we do it? I need to just delete this. Okay, so instead of pointing this head to this, I will just point it to this. So this node will be ignored. So that's how I delete the data or node at the beginning. And then what is the next one that I have? So deletion at the end. So it's very simple. Again, how do we do the deletion at the end? So any guess? So guys, I want to delete this node. So what should I do? Okay, so let me just show you. I need to delete this node. So you all know that, just ignore this. You have null here. Okay, so you store here the address of this node. Instead of storing the address of this node, you will make this as null. That's it. So you are deleting the node at the end. That's how I delete the node at the end. What is the next thing that I have? So let's check. Delete after a specified node. It's very simple again. Okay, let me show you. So imagine I need to delete this. After this, I need to delete this. How do I delete that? Let me just show you. What is the logic that I should remember? I need to delete this. Okay. So instead of storing the address of this node, I will just store the address of this node. That's it. Okay. I will delete this node completely. This is how I will be deleting the specified node. Moving forward to the next one that I have. So traversing in the sense you will be visiting each and every node one by one. So that is what we call it as a traversing, and you will be searching for the element. So you will keep matching the elements one by one in each and every node. That is what we call it as a searching. This is the different operations that we perform with respect to the singly linked list. Okay. With this, I have come to an end of this session with respect to the linked list. So the programs, let us discuss in the lab. Thank you.